the show till now. I know there will be some kind of a soccer game a bit later today, so let's get started. So the talk will be about not only the neural network API, it will be more about neural networks, machine deep learning running on the edge on Android devices. And I will be providing lots and lots of links for you to read. So be warned, if you really will follow all the links, you will be lost for 2 months. By the way, that's a painting in oil. I own it since '88, so that should tell you that I'm in this field since quite a while. Okay. Just a few words about Androidian. We are doing lots of stuff. We were working on Android before it has been announced officially, but we are also in industrial use cases, consulting for home appliance companies and cars and whatever. Okay, what is this AI, ML, whatever, all about? The Turing test, I think, is one of the main topics. It proves, or it shall prove, that a machine is capable of behaving like a human, more or less. That's a big step, a big foot to get into it. Machine learning in the last 20 years, more or less, was all about pre-canned, pre-programmed applications and algorithms. Them are listed here. There are way more. The important part to know is that with machine learning, you really had to know what you're talking about. You had to know your models, and everything had to be more or less pre-canned. The whole system was not capable of handling edge cases, so it was doing its job, but just doing its job, nothing else. With neural networks and especially deep learning, the story is very different, because you are starting to train a model, and in the end, the model is capable of handling cases which are which differ from the trained model quite a bit, like 20–30% noise you can add and it still would work. I can show you a bit later. Rules of thumb. Just to start with, a lot of projects are started these days just because it's machine learning and it's a checkbox item to be checked. But that's not the way to do it. You really need to know what you're doing. You need to know your data. You need to know what you want to achieve. And also, the second sentence, it's better to have a smaller set with good data instead of a huge set which is blurry, and it will just guarantee that you will not ending up with a model which can be used. And obviously, since we're talking about Android, the question is, how could I use machine learning on these small little devices? And in fact, there are two parts of the whole story. I have some echo here. To train the model, mobile devices are not really suitable. You can later on update trained models based on incoming data. That's possible. But the main model needs to be trained on capable machines, usually with NVIDIA GPU arrays or hardware which is got some oomph. That's very important. Otherwise, you will be ending up training your model for 2 weeks, and after 2 weeks, you will find out that it's running or not behaving like you would wish for, and you lost 2 weeks. That said, you can use the cloud. but be warned, these GPU heavy systems are very expensive if you run them on the cloud, so your bill will be relevant, let's put it this way. Okay, and we do have a lot of different frameworks. For Android, TensorFlow is currently more or less the winner. TensorFlow Lite is gaining momentum, but there are subtle differences, and I will be talking about those just a little bit. And that's the other side of the edge. That's a block diagram of a complete machine learning system, which is using backend and small little devices. And the whole system is able to learn based on user behavior and changes of the model. So it's a full round-trip kind of AI machinery, just as an example. Okay, why now? As already said, machine learning or neural networks are in the market since the late 80s, at least. Hinton started the whole thing in the 60s. Why did it take so long? The problem till some years ago was just performance of the machines. So it was just too slow to get these models running. But also some important developments like the rectified linear units and other small little components added up to the whole environment of machine learning and deep learning, and led to, I would say, an avalanche since 2010 and especially 2015. So that means that a paper you are going to read these days, which is like 4 years old, it's collecting dust. Even if it's 3 months old, you need to be careful. There might be an update which would just blow the old 3-month-old paper out of the shoes, right? Example. Natural language understanding, natural language analysis has been done with machine learning since many, many years, but again, pre-canned, you had to know all the phonemes, you had to pre-program the rules step by step. Everything was really implemented like a program. But that's so 2015, right? 2016 maybe. Now we are talking about vectors. What does this mean? You can do math with vectors and words, like king minus man plus woman equals to queen. And the paper which shows how to do that is listed here. And there's also an online tool you can play with. And you see those are a few examples of vectors like queen, king. And if you look carefully, the distance and the angle of the vectors between queen and king and woman and man are really close. And that means the vector mathematics really works. And you can play around with these with words, and you can add some more. So have fun with this one. It's just mind-blowing to do word math, right? But that means that the deep learning model, if it's trained correctly, it can do really very interesting stuff without you implementing the whole algorithm in the old-fashioned. 2015, 2016. Statistical machine translation was winning all of the comparisons till 2015 against neural networks. But between 2015 and 16, neural network machine translation just started to be more performant. And looking back, I would say it's time to leave statistical machine translation and to learn something new, like neural network-based machine translation. What is it for? I will be showing some more examples, but those are the obvious ones. Typically, classifications, chatbots could be done with neural networks, and I've seen quite a lot of interesting projects here. Object detection, but process automation could also be done with neural networks, also on Android phones. So rule-based engines like coming home, going to work, adding security switches and stuff like that. So based on your user behavior, a system could automatically update its settings, stuff like that. Just a few components. I think I should not get into those because we would be lost. But those are the basic parts or components of a neural network. Neurons, we have cost and error functions, which are very important because the cost function tells you the difference between the result you are looking for and the result of the inference model or the result the model gives you. And to get to the result, we are using functionalities like gradient descent, and we need to reduce overfitting and stuff. I will be available for questions in this regard after the talk. 1960, Geoff Hinton started with the perceptron. That was just a very simple neuron. These days we are talking about tonnage and ReLU, maybe sigmoid. Those functions are speeding up the learning process, and I will show a short video showing the difference. Once more again, some of the use cases, but I think we already got there. Now, edge computing. A lot of people these days are still talking about cloud-based computing. Everything needs to be in the cloud. But I think that's 2017. 2018, there's a switch to edge computing, which means a lot of functionality moves back from the cloud to the devices because they're just capable of doing a lot of work without the need of getting into the cloud and doing network or adding network latencies and also cost. And adds privacy. That means the data stays on the device. It's your data. The big guys like Google are not getting your data. That's very important for a lot of people and a lot of use cases. Top right, you see some well-known chip companies, but everything else is startups doing neuro accelerator chips. And it's not a complete list. It should tell you that currently a lot of money and a lot of startups are working on solutions to improve performance. And some of these chips will be ending up in your mobile handsets. If you look into the Huawei handset product line with the Kirin 970, that already has a neural accelerator on it, and expect that a neural accelerator will be just a basic component of modern headsets. So, what's the drawback? Drawback is if you're using machine learning, deep learning models as part of your application, you must be careful and it must make sense. Careful means you're adding up a lot of memory to the application. We are talking usually about 40 megabytes or more. I've seen 300 megabyte models, which it's not that easy to handle, so you need to make sure that the application stays small and you download the model on the fly if needed. We are talking about power consumption, and that means because you need to load the model into your application and exchange weights and so forth. So the power consumption is one of the critical parts these days. And how many have already used TensorFlow these days? Okay. So there are two offerings for TensorFlow users on mobile. TensorFlow for mobile is a stripped-down version of TensorFlow. The new TensorFlow version, TensorFlow Lite, is even more reduced. And it's important to know that as a developer, you need to decide which one of these two to use. The TensorFlow Lite is light, but it has one important feature. It's supporting the neural network API. What that means, I will explain shortly. But usually these days, most developers stick with TensorFlow for mobile because they have already complex models running. And TensorFlow Lite is yet not capable of handling complex models. It will change. But there's also TensorFlow available for JavaScript for the browser. I will show also a running application. And the rules of thumb, again, train your models on big systems and let them run on your mobile device. Do not use the neural network API directly. Why, I will explain too shortly. Is the comparison between TensorFlow for mobile and TensorFlow Lite. It really depends on your models and your needs. The issue is currently you really need to define and decide the line between both frameworks. It's possible to migrate from TensorFlow for mobile to TensorFlow Lite during your project, but you need to check how the smaller model works, and sometimes you need to really change like 50% of the model to be able to run it with TensorFlow Lite. But the last sentence is also of high importance. It's the way to go in the future. So it's obvious that TensorFlow Lite will be more and more capable of doing things. If you're using TensorFlow on desktop systems, you need to compile and generate model data for TensorFlow Lite, but that's an automatic process. The issue here is sometimes you're using operations which are not supported by TensorFlow Lite and you're getting runtime errors. So be aware of runtime errors and check. Just a few links. And let's see. Okay. The neural network API has been announced last year for one very specific reason. The issue is that companies like Huawei and LG and so forth started to provide their own private API for neural networks. And that's not the way to do it. It's better to have a general API, and this way it's easier to support the hardware accelerators via the high-level frameworks. So porting is very, very easier. Okay, I have some issue with my microphone. Okay, so it works. I think that's a very important graphic. It explains how a neural network API works. If your phone does not support any neural accelerator, it just will use the CPU. This being that, it's still worthwhile using it because the speed up is still like 3 or 4 times in comparison to Java implementation. The neural network API is implemented in C, so it's a native implementation, and the speed up factor is quite substantial. But as soon as you do have a DSP or GSP or whatever neural network accelerator, the neural network API is going to use it, and then the fun starts. That's one of the programmers I was talking to. He did some comparisons, and it's quite obvious that it's worthwhile using that NN API, even if you just run it on a system without any specific hardware. Okay. This microphone kills me, but it's good. Bottom of that slide, you see a reference to Caffe, which is an alternative to TensorFlow. And just check the GitHub link, and you will see that you can use NN API also against unsupported, officially unsupported frameworks like Caffe easily. It's not a big deal, and it's very interesting to read. Okay. Just show some applications which can be downloaded. The links are also provided. You see in the top the classification results and the probabilities of 4 different applications. And you also see that not everything works as expected. The class is just not detected. It's a mousetrap. It could be a mousetrap, by the way. Money, not detected at all. Maybe a wallet. On the other hand, notebook, laptop works, and even the video is being detected. Those are very simple classification topics. I think it's a very good start. It's a different application which is capable of showing the different objects on the video with some overlays. Still, you see already that the classification results are not always what you expect, right? Dining table, keyboard. So the higher the number, the better the probability. So everything above 80%, I think, is good. Everything below, you should be really careful about your results, which means whatever you get as a result, be in doubt. But here you see that even the persons in the video are being detected. And that's running on a Pixel XL. No GPU, no fancy accelerators, and it's running against a real-time video. Now the same, one of the use cases is translating into Chinese based on the projects you see. I think that's a very interesting topic. Also, of course, here it's important to always be in doubt. I will show some funny example later. But I think that's a very interesting use case to have a real-time translator between detecting an object in English and Chinese in that case. And it shows the top 3 results. So that also gives some hint that the user interface should take care of results which are ambiguous. And that's TensorFlow JS. So it's running in the browser in real time. And mouse, computer mouse. not bad for a neural network running in a browser, right? But it's undecided sometimes. Let's put it this way. So really be careful, because if your mindset is not to be careful, you will end up in big trouble. Especially if you're doing translations. Okay. Let's stop this. Those were examples for very simplified classification issues. I will get into deeper classification models next. But again, those were the good ones. But now look in what the same model gives you against the same object. A mouse could be a mouse. It can also be a toilet seat, depending on the angle. So I think it's important to remember these three results, because they just show the issue. Okay, ML-Kit. I think there was a presentation yesterday about the ML-Kit from Google. It's in beta yet, but it's already promising a lot of power. It will be the framework to go to if you do have standard, not so special kind of use cases like facial detection and so forth. It can run locally. It can also run in the cloud. For some models, you can decide, which is a good thing, though the privacy part still is supported, at least partially. There are interesting code labs available, so it's easy to get in and to fool around. It's based on Firebase, if we are talking about cloud. And it's important to know that for the simple use cases, you can work locally. For the custom ones, you need to upload your model to Firebase. It still can be private, and you still can make sure that the data is not public or being available to the big guys, but it's not on your servers, right? I think it's worthwhile, or it's easy to see that ML-Kit will change the way of how developers are going to use machine learning on a mobile device. It's more or less like, instead of 2 weeks of work, it's like 3 hours and you're done. For example, facial recognition. So the question here is, where's the line between using ML-Kit and your own model? And the simple question is, okay, it's easy to detect a face with TensorFlow models. It's a 20-line kind of program. But the question, is the person smiling? It's a bit more complex. And ML-Kit already gives you those features based on real-time video and images. And I think that supports already a lot of use cases, and a lot of applications can be done based on this kind of result. With no need for you to learn TensorFlow, to learn the models, and to update the terrain and everything. It's just built in and just use it. I think it's a commodity, right? It even works against, or if the person is not looking straight forward into the camera, so your mileage may vary. So for the landmark detection, like eyes, left, right eye, and so forth, it depends on the angles, but you get already results of the in relative to the angle, so you can always decide if it's good or not for you. So for simple classifications, I think it's already worthwhile going with MLKit instead of TensorFlow, TensorFlow Lite. For private business logic or non-standard business logic, obviously there's no choice. You have to do it yourself. Sometimes that's if the business logic is the main part of your application in this regard, go with it and invest some more time and money in your own solution. Okay. There's a very interesting online tool, also browser-based, and that will be the next video. It shows you, if you're starting with neural networks and so forth, it gives you some ideas of how neural networks are working. So it's a very simplified neural network with just 3 layers, one hidden layer, and with mouse over you can see the weights, the default initial weights. You can change how the neurons do their math and so forth, and the epochs, those are the learning cycles. And I'm switching to a more complex one, which needs to distinguish between the orange and the blue points. And you see after like 250 runs, it's capable of doing that. If you add one more layer with 3, 4 neurons, you will see that it's getting to the result faster. You see the lost function top right. And if you change the activation and the learning rate and so forth, you really see the difference. If you are, getting to a too fast learning rate, 0.3 is good enough, but it has some issues in the beginning. Again, you see how each, now one. I think that's not getting to any conclusion, see? So it's a very simplified model, but it gives you more or less insights into how a neural network, a deep learning network, works internally and what kind of parameters to watch for. And you can already compare. Here you see some really funny result, but in the end, it works, but I would not use it in production. That's better. So have a look. I think I need to save some time. Okay. For everyone who started with TensorFlow, there was some interesting offer available since quite a while. Keras, done by a TensorFlow programmer, that's sitting on top of TensorFlow, but not only TensorFlow, it's also supporting Viano and some more frameworks. The main topic here is that Keras sets up your model based on proven weights, proven rules. So it does a lot of setup work for you to start with, and you can already get into your model very fast using Keras. TensorLayer has just been announced. I had no time yet to look into it, so please go ahead. That might be very interesting. Okay, I have 5 more minutes. Okay. There are a lot of sensors on mobile devices, right? Just a few examples, gravity accelerometer and so forth. And there's an interesting paper which has been published on Kaggle based on a study, and that was about how to analyze sensor data with deep learning models. And one of the questions was, can the activities be separated by the model based on gyroscope and so forth? And the answer is obviously yes. Can the person be extracted by the behavior or the sensoric data? Answer is yes. It's getting worse. Can I predict a specific user based on the walking signals? Yes. Or, walking styles using staircases. Can I gain some health data based on sensoric data? Not so sure, but maybe. But the team came to the conclusion that it's obviously possible to find out a specific person running or using the phone. So that's a kind of a privacy issue. iOS and also Android is trying to not help developers to figure out which person is using what device, but with sensors you might be able to do that regardless. And the team just came to the conclusion for just a few weeks of work they came very far. One more paper. Some more alternatives. If you want to get into machine learning, you can also use a Raspberry Pi with the Movideo's neural compute stick. If one is not good enough, if one gives you 5 to 6 performance increase, you can just take them up like using 4 or 5. And we are talking about $50, $60 per stick. And that's a new hardware. If you're into new voice programming, you can use microphone array, including ARM CPU and everything, for $90. I think, and the re-speaker is available since last week. And finally, some of the links to get you started with the whole topic. Highly recommended Stanford classes, Ritchie and G. The video course from Dr. Krohn, Fast AI, obviously, making Unit uncool again. Some more repos. And interesting, for example, Facebook FAIR, Facebook AI research, the Detectron system which helped Facebook to find persons in each uploaded photo. That project was internally only, but it's open source in 3 months. And it's very interesting to see how they did this. Yeah, and that's it. Thank you.